The examples in this video go with Lesson 7.2, Confidence Intervals for a Population Mean, Standard Deviation Unknown. Example 1. Use Table A3 to find the critical value t sub alpha over 2 needed to construct a confidence interval of the given level with the given sample size. Part A, level 95% with n equals 15. Okay, remember, in order to use Table A3, we need to know the degrees of freedom. And our degrees of freedom is defined to be n minus 1. So for Part A, the degrees of freedom will be 15 minus 1, or 14. Now what we're going to do is we're going to use Table A3 to pull out our area value that's underneath the curve, and we are going to look under column 95%, line 14. So let's pull up Table A3, and I've had to cut mine in half in order to fit on the page, but y'all should fit onto one page there. The 95% column is right here. This is the 1, 2, 3, 4, the fifth column, and 14 is going to be located right here. And so the number that we want is going to be right here on line 14, but we need to go up the fifth column. So 1, 2, 3, 4, 5, and that means that the solution to our problem, or the question that's being asked, is our t sub alpha over 2 is 2.145, or our t value. This is what we sometimes call it. Okay, Part B. We want a level of 99% with n is equal to 22. We'll start off, we'll figure out what the degrees of freedom are. That's going to be n minus 1, so we have 22 minus 1, which is going to be 21. We are going to be looking on line 21, column 99%. So let's go back over here to Table A3, and we will find, I'm going to change colors here so that we don't get confused. All right, this time I'm using green. All right, we want to be on line 21. That's right here. And then the column 99%, that's this one right here. So this is 1, 2, 3, the fourth one from the right. So 1, 2, 3, 4 from the right. And so our t value is going to be right here, 2.831. 2.831. Okay, Part C, level 90%, n is equal to 63. We'll go to our degrees of freedom. That's going to be n minus 1, or 63 minus 1. This is 62. We're going to be on line 62, column 90%. All right, and again, I'm going to change colors here. So line 62, column 90%. We'll go back over here, and I notice that I go from 40 to 50 to 60 to 80. I do not have a line 62. Well, your book says if you don't have a line 62, go backwards or lower to the next lowest one. So that means we're going to be using line 60. And then the 90% column is right here. And so it looks like our t sub alpha over 2, our t value, is right here, 1.671. Oops. Part D, we want a confidence level of 95% with n is equal to 2. That means our degrees of freedom will be 2 minus 1, or 1. And so we're going to be on line 1, column 95%. Let me change colors one last time here. So line 1, 95%. All right, line 1, that's not too bad. That's the one right here on the tippity top. And then 95% we've already done. That's this one right here, 1, 2, 3, 4, the fifth one from the left. So 1, 2, 3, 4, this one. And so our t value, pretty big this time, 12.706. Example 2. In each of the following situations, state whether the methods of this section should be used to construct a confidence interval for the population mean. Assume that sigma is unknown. Part A. A simple random sample of size 8 is drawn from a distribution that is approximately normal. Okay, so what we have here, in this case, we have our random sample. That's good. We have a small sample size. Okay, that's all right. And we know that the population there was approximately normal. So we only need to have one of those. Let's see. We either need to have a large sample size or we need to know that the population is normal. And what we have is we have the small sample size, but we have the normal population there. So we're okay. So part A, yes, we can use the t-distribution to try and find a confidence interval for that particular sample. All right, part B, we have a simple random sample of size 15 drawn from a distribution that is not close to normal. So again, we've got our random sample, that's okay. We have a small sample size, that's okay, but we know our distribution is not close to normal. Our population is not even close to being normal. And I actually either had to have a large sample size up here, or I needed to know that we had a normal population or something that was close to being normal, and I don't have either one of those. So for part B, no, this would not be appropriate to use the t-distribution for this particular sample. Part C, a simple random sample of size 150 is drawn from a distribution that is not close to normal. We have our random sample right here. We're at size 150. Now this is greater than 30, so this is considered to be a large sample, okay? And our population, again, not close to normal. Well, remember, I either need to have a large sample, which I have, or I need to know that my population was close to normal. And I have this one. I don't have that one, but it's okay. As long as I have this one here, we can use the t-distribution to try and find a confidence interval for that particular sample. All right, part D, a non-random sample is drawn. We know that it's not a random sample, and there's not even any point in figuring out what the size is, because the fact that it's a random sample is one of my definite things that has to happen in order to be able to use the student's t-distribution. And since I do not have a random sample, we will not use the t-distribution to find a confidence interval for this particular sample. Example 3, a potato chip company wants to evaluate the accuracy of its potato chip bag filling machine. Bags are labeled as containing 8 ounces of potato chips. A simple random sample of 12 bags had mean weight 8.12 ounces with a sample standard deviation of 0.1 ounces. Construct a 99% confidence interval for the population mean weight of bags of potato chips. All right. Let's go back and look at the directions. Okay, here's our directions for how to compute a confidence interval when we don't have sigma. Now they did give us a standard deviation, but it was not the population standard deviation. So we're going to follow these directions, okay? Number one, compute the mean for the sample, that's x bar, and S, this is the standard deviation for the sample if they're not given. Okay, now what this means, let me go ahead and say this. Sometimes you're going to be given a list of data that you have to put in your calculator to find the mean and the standard deviation for using the 1-bar stats. And when that happens, be sure that you use, well, the x bar that they give you and use the SX. Do not use the sigma. Remember, that goes with the population. So if we're trying to follow these directions, remember, the population standard deviation is unknown, so do not use that in your calculator. Use the SX. All right, now with that being said, let's go back to the problem, because they actually did give me the information right here. The mean weight, 8.12 ounces. So I do have my X bar. This is 8.12. And the sample standard deviation, S, they also gave me right here of 0.1. Okay, let's see what we need to do next. Number 2, we want to find the degrees of freedom. This is n-1, and the critical value, which is going to come from table A3. Okay. All right. The degrees of freedom. Remember, this is n-1, and n they conveniently gave to me to be 12. So our degrees of freedom will be 12 minus 1, which is 11. Okay. And our confidence interval, no, our confidence level, sorry. Take this off. And I'm going to change this. All right, our confidence level, they gave us to be 99%. Okay. So now I'm going to go over to table A3, and I am going to get my t-value. I'm going to be on line 11, and I'm going to be on column 99%. All right, so let's see. Line 11 is going to be right here. And then column 99%, 1, 2, 3, the fourth one from the right. It's right here. And so it looks like I want this value right here, 3.106. Okay. Next thing I want to do, compute the standard error. This is going to be the standard deviation divided by the square root of n, and then multiply it by the critical value to obtain the margin of error. Okay. The standard error is going to be our standard deviation, 0.1, divided by the square root of 12, because that's our n. All right, let's put this in our handy dandy calculator. And I'm going to round this out to 3 decimal places. And this is giving me 0.029. And I'm rounding it out 3 decimal places because my t-value down here is also at 3 decimal places. It's actually better to keep the entire decimal there. So if you can keep that number in your calculator, that would be great. And use that in your calculations, and then we won't be quite so far off to the actual confidence interval. Okay, the next thing we're supposed to do is find our margin of error. And the margin of error is going to be our t-value here, 3.106, times the standard error we just found here, 0.029. All right, and I'm going to put this in my calculator. And this is giving me 0.0, and I've got 896, but that's going to round that up, so this is going to be 0.090. And I did use the entire decimal here. I didn't use the 0.029. I used all the rest of the decimals were back there behind that. Okay, so now we have our margin of error. Now, to get our confidence interval, all we're going to do is we're going to take our mean and we're going to add the margin of error. That's going to give us the upper end of our confidence interval. And then we're going to take the mean and we're going to subtract the margin of error, and that's going to give us the lower end of our confidence interval. Okay, so our confidence interval will be our mean, which we said was 8.12. And remember, we're going to add the margin of error. This is going to give us the upper end. And then we're going to take our mean, and we're going to subtract that margin of error. And that's going to give us the lower end of our confidence interval. And this is giving me 8.21 for the upper end. And 8.03 for the lower end. And y'all, when we write our confidence interval, we usually write it as an ordered pair. The lower one goes on the left, and then the upper one goes on the right. And of course, there's a comma in the middle separating the two of them. So I would write my answer as parentheses 8.03, comma 8.21 parentheses. Okay. Now, it didn't ask me to do this, but we're going to do it anyway because it's a good idea to interpret the results. Okay? Because every once in a while you're asked to interpret your results. All right. Our interpretation. We are confident. We're very confident. In fact, we are 99% confident that the true mean weight of those potato chips for the population lies between our lower interval there, 8.03 ounces, and 8.21 ounces. So there's our interpretation. We're 99% confident that the true mean weight of potato chip bags lies between 8.03 ounces and 8.21 ounces. And that true mean weight, again, would be the mean weight for the population. So for all of the potato chip bags that are made on that particular day. Example 4, a company has developed a new type of light bulb and wants to estimate its mean lifetime. A simple random sample of 100 bulbs had a sample mean lifetime of 750.2 hours with a sample standard deviation of 30 hours. Construct a 95% confidence interval for the population mean lifetime of all bulbs manufactured by this new process. Okay, first thing we need is we need the mean and the standard deviation. And the mean has been given to us right here, 750.2. And we need a standard deviation for the sample, which they also gave us to be 30. And they told us the number of light bulbs in our sample here is 100. And we know that we want our confidence level to be 95%. And we are trying to find a confidence interval. for where that true mean actually falls. And hopefully it will fall, well, it should fall between the two endpoints that we find. Okay, we need some degrees of freedom. And we can find that from n minus 1. So 100 minus 1, this is going to give me 99. We go back to table A3. We want to be on line 99, column 95%. And I see that I don't have a line 99, so remember I have to back up to the next one that's closest to it, and that is 80. So we're not going to round up to 100. We're always going to be going down. All right, so we're on line 80, and we want it to be at 95%. That's this column right here. And so our T, 1.990. 1.990. Okay, we need to calculate the standard error. The standard error, remember, was the sample standard deviation divided by the square root of n. Well, this is just going to give me 3 because we'll have 30 over 10, which is 3. And we want the margin of error. That's going to be our standard error we just found times our t value down there, 1.990. Let's see what the calculator gives us. And this is giving me 5.97. All right, we are ready to find our confidence interval. Remember, we want to take our mean here, 750.2, and we're going to add the margin of error. This is going to give me the upper end of my confidence interval. And we will take the mean, 750.2, and we will subtract the margin of error, and this will give me the lower end of my confidence interval. And I'm getting 756.17. That's the upper end. And 744.23, which will give me the lower end. And so my confidence interval, remember we write this as an ordered pair, we'll have 744.23, comma, 756.17. There's my confidence interval. And again, we weren't asked, but we might as well get in the habit so that when we're asked, we can do this okay. We're going to interpret our results here. This is our interval, and we're pretty sure. How sure are we? We are 95% sure. We are 95% certain that the population mean lifetime. I'm getting all this from that last sentence in the problem. Of all bulbs manufactured by this new process lies between 744.23 hours and 756.17. hours. Example 5, let x bar equal 45.56, s equals 6.84, and n equal 15. Part A, how many degrees of freedom are there? Well, the degrees of freedom, that's just n minus 1. So in this case, we'll have 15 minus 1, or 14 degrees of freedom. Part B, find the critical value T sub alpha over 2 for a 99% confidence interval. This means we're going to need table A3, and I know we need table A3 because I have the sample standard deviation here, not the population standard deviation. Okay, so I'm going to be on line 14 and column 99%. Let's go to table A3. All right, line 14, here it is. 99%, 1, 2, 3. This is the fourth one from the right. That's this one right here. That means our T value that we're looking for, 2.977. Okay. Use the critical value, this is part C, along with the information in the display to construct a 99% confidence interval for the population mean. Okay, we need a standard error because we're going to have to get to the margin of error in order to have a confidence interval. All right, our standard error is the standard deviation divided by the square root of n. And I'm going to round this to 3 decimal places. So in the calculator, we have 6.84 over the square root of 15. And this gives me 1.766. Our margin of error is going to be our T value we found, 2.977, times the standard error, 1.766. This is going to give me 5.258. And if you're doing this along with me and you're not getting the same numbers, it's because I've just left the entire decimal in the calculator here. I didn't use 1.776. I used 1.766080, blah, 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 and multiplied that here. Okay. All right, the confidence interval, remember we're going to take our mean, 45.56, and we want to add that margin of error. And then we're going to take the mean, and we are going to subtract the margin of error there. Now, both of these answers, I'm going to round to 2 decimal places. And the reason I'm going to round them to 2 decimal places is because the mean right here is rounded to 2 decimal places. All right, so 45.56 plus that margin of error. This is giving me 50.82. This is the upper end. And then the lower end, so we'll have 45.56 minus this gives me 40.30. And so it looks like my confidence interval is 40.30 to 50.82. Now, doing an interpretation here doesn't make a whole lot of sense because we don't have a context of a problem to put it into, but if we did, we would say that we are 99% confident that the population mean falls between 40.3 and 50.82. Example 6, let x bar be 8.5963 and the standard deviation be 0.11213 and n equal to 10. Part A, how many degrees of freedom are there? The first thing I want to do is fix this. That is supposed to be an x bar. Okay. All right, the degrees of freedom, remember, this is just n minus 1. So in our case, we're looking at 9. Part B, find the critical value T sub alpha over 2 for a 99% confidence interval. This is going to come from table A3. We're going to be on line 9, column 99%. And we're going to pull up table A3. Line 9 is right here. And 99%, that was the fourth one from the right. So that's right here. And that means the t value we want, 3.250. And now we're going to construct our confidence interval. Well, remember the first thing we need is a standard error, and that is the standard deviation for the sample, 11213, divided by the square root of n, our sample size. And this is giving me 0.03. Let's see, how many decimal places we want to go out? 4 decimal places. So 0.355 for our standard error. Okay. The margin of error, remember, that's our t value, 3.250, times the standard error we just found. This is going to give me 0.1152. And then to find the confidence interval, we're going to take the mean, 8.5963, and we are going to add the margin of error. This is going to give us the upper end, and then we're going to take that and we're going to subtract the margin of error, and this will give us the lower end of our confidence interval. All right, the upper end is 8.7115, and then the lower end $8.4808. And remember, the reason I'm rounding to 4 decimal places is because in the beginning the mean was also rounded to 4 decimal places. All right, here's my confidence interval. 8.4808, that's the lower end, comma, 8.7115, this is the upper end.